Using this demonstration panel, we will show the APS 438 air-powered saw cutting a section out, slicing the membrane from between the tubes, and then prepping them with a high-speed beveler. The first step is to align a weld tab at the cut line and tack weld it in 2 places, being sure to keep it flat against the panel. In this demonstration, we are welding directly to the tube. Other methods can be used to attach the weld tab to the membrane. With a second weld tab attached to the track is slid onto the first weld tab, and the nut is fastened to keep it from slipping off. Next, the track is leveled. And the second weld tab is tacked into position. With both weld tabs securely in place, the nuts holding the track to the tabs are tightened. Next, the saw is slid onto the track. The air is connected, and cutting may begin. Please notice the technique. Proper cutting requires the blade to be moved back and forth while plunging the saw into the tubes. By using this technique, the saw blade develops a cut path that helps ensure a smooth, square cut. If the blade were simply plunged in and forced to cut as if a piece of plywood, the blade deviates and is forced either up or down, creating an uneven cut. Moving the blade back and forth also helps the material from being overheated. Overheating the material causes it to flow into the blade and slows a cutting action. When the bottom cut is finished, the air is disconnected, the saw is removed, the track is unbolted and removed from the panel. Next, a piece of shim stock is slid into the bottom cut to help prevent slag and other debris from falling down the tubes. When cutting boiler tube panels with clearance problems, we have the APS 438 LP low profile, which requires only 7.5 inches of clearance. For the top cut, the track is attached to the panel using the same method as shown before. The cutting technique is also the same. Moving the saw back and forth while plunging helps assure efficient, clean, square cuts. With a safety stop in the down position, the track is aligned with the cut mark. The track weld tabs are tack welded into position for the first vertical cut. The saw is then slid onto the track and the brake handle is tightened. With the air connected, the cutting can begin. In the vertical position, it becomes difficult to move the saw up and down, and therefore it becomes important to pivot the saw off the material, helping to avoid overheating the saw blade. Once the first vertical cut is done, these weld tabs can be removed, since they will not be used in this position again. Since the weld tabs can be used any number of times, it is important to remove old weld material so they will lay flat the next time they are used. When the second vertical cut is complete, the panel is removed, and the track is remounted to the lower weld tabs for membrane removal. Once the track has been mounted, the membrane bracket is slid onto the track. As you can see, the membrane track can be rotated to different positions. The membrane removal blade is mounted using a flange made expressly for this blade. It has extra support to help seat the blade properly on the saw. With the blade secured, the saw is mounted to the membrane bracket, and the saw brake is tightened. Once the blade is lined up with the membrane to be cut, the membrane bracket locking handle is secured, and membrane removal can begin. With new blades, if the membrane is particularly hard, it is sometimes necessary to dress the wheel to remove any material buildup, which may slow the cutting action. The membrane bracket can be reversed so the saw can get into the corners or get around other obstacles. The saw can also be mounted directly to the track in order to get into the extremely tight spots. For the upper membrane, the membrane bracket is mounted in the inverted position and used in the same manner. Once the membrane is removed, there are a variety of tools available to end prep the tubes. The first type we are showing is the high-speed. Later in the video, we will be showing the Milhog ID clamping end prep tools. Using the track chassis and post assembly in conjunction with high-speed tools is an efficient method of beveling small diameter tubes. The HHB 5000 is mounted to the chassis and the pilot is inserted into the tube. With the chip shield in place and the air connected, the tubes are ready to be beveled. High-speed tools bevel so fast, a stop is used to help prevent over-beveling. Once a stop is set, all tubes will be beveled to the same height, making new tube fit-up more efficient. High-speed tools are offered in 4 models. 2 models can be track-mounted or handheld, and 2 are right-angle drive models. All high-speed models share interchangeable cutter heads, pilots, and cutting bits. High-speed tools are ideal for low-alloy tubes. Stainless steel and high-chrome tubes will sometimes work harder if excess material is removed. As you can see, the setup time is minimal and the beveling takes only seconds. Since high-speed tools throw hot chips, it is mandatory for the operator and others in the area of operation to wear protective clothing, including goggles, face shields, hard hats, gloves, long sleeves, and welding jackets. All ESCO end prep tools have critical width dimension for getting into limited access areas, and all produce mirror finishes on the tube ends without cutting fluid. Cut line indicators that are attached to the track align the saw to the cut mark. And by turning the crank handle, the wedges are tightened against the tube panel, securely holding the track in position. The cutting action is the same as before. Plunging the saw in and out of the work while moving it back and forth is important to maintain an even square cut. This APS is equipped with a reverse throttle handle, which is particularly useful for cutting boiler tube panels when using the quick clamp on this kind of layout. The throttle handle has been rotated 180 degrees so the operator may more easily reach it. Using the 12-inch saw blade, the maximum depth of cut is 4 3/8 inch. The air requirement is 90 psi at 80 CFM. All saws come equipped with 3/4 inch air hose, and in order to maintain proper power, smaller hoses should not be used.